Good evening, Shashan sir. Good evening, everyone.
Good morning, everyone.
Good evening, sir. Good evening, ma'am.
Good evening, ma'am. Good evening, sir.
Good
Sorry, good,
evening.
good evening, good evening. So, today I'll be taking the session for you, and today's session will be on system internals. Okay, so I'll share my screen now. So, is my screen visible to everyone?
Yes, sir.
Yes, sir.
Okay, so today's topic is system internals. So, in system internals, we'll be studying basic features, basic operations in our system. So first we will study how we can what is the process that is going on when we power on a system. Is anyone aware of what happens when a system is switched on? Is anyone aware? You can reply. Okay. Uh, you can reply. Does anyone know? Okay, fine. So process the process that occurs is 1 second. Why is it going like this? So the first process will be once we switch on the power supply unit present in our CPU will be like turning the AC into DC current. Then the second process will be uh, like once the power supply unit converts AC to DC, this DC charge is transferred to our motherboard. And this motherboard has connection with our BIOS, other hard drives, and also to the CPU also. So the BIOS is the main factor that initiates the power on self test, that is post. So once the uh, power supply unit changes AC to DC, then uh, this later gives the power to motherboard. Then the motherboard then uh, passes the power to BIOS. BIOS is basic input output system. So it just initiates the power on self test. It is often referred to as post. And in this post they check whether the power supply is proper to every part of the system. Then once it is uh, given a positive signal, one beep will be seen. If it is a negative signal, two beeps will be there, so that the system understand that the somewhere the power issue is there. So in case of one beep, the next process is that it initiates hardware components. Okay. Then the process is there are hardware BIOS which starts running, and hence it initiates the once the hardware components are running. Once the hardware components are running, it will initiate the processor, that is our CPU, and the memory. Okay, this is the process that happens when we switch on the power. Okay, so the BIOS and the post are very important. Usually, in case if you sit for any interview and all, they used to ask, what is BIOS, what is post. So if anyone have doubt, you can ask, or else I'll move on to next topic. Shall I move on to next topic?
Yes,
Okay,
sure.
fine. Now I'll move on to kernel. What is kernel? Actually, the kernel is an interface which you can say it is a software which is present between the hardware components as well as our software applications. Actually, kernel helps to link the hardware components with the software application. For example, if you are using a app which requires the permission of use of camera, so it is the kernel which provides the permission. So the kernel help to access the hardware components of our system with the software applications. Usually, different operating system have different kernels, and kernel we can say it is a large code which can be which is in both C language as well as the assembly language. ASM means assembly language. Okay. Then the in iOS the kernel is the Darwin, and in uh, Windows NT kernel is used. In Android Linux kernel is used, and the kernel describe the amount of resources to be used by the application, how much resource it can be used. For example, once the application requires a particular set of data, it is the kernel which gives the system call that uh, it can give the required amount of data to the application. Once kernel approves, only we get the data. Okay, so kernel is very important in managing as well as security, because in case of security we can say the kernel has various privileges given, so that particular privileges are accessed by particular uh, applications only. So this is a common Android OS architecture. You can see Linux kernel is the base, above which library layer is there, application framework layer is there, applications are there. So in Linux kernel, you can see these following hardwares are connected to our applications. So everything we can add a new kernel to our system, but if we don't know how to add, it can completely damage our system, because kernel is something which mediates every action of our system. Then CPU, central processing unit. So we can say CPU is the brain of the system. So in CPU, there are mainly three components, three parts: control unit, AL, arithmetic and logical unit, cache memory. And in control unit, they controls the operations. In ALU, the mathematical operations are controlled. In cache memory, it consists of certain memory locations called registers. Actually, cache memory is for faster transfer of instructions. Actually, in case of memory, there are primary memory and the secondary memory. Uh, in primary memory, it comes the RAM and ROM. In secondary memory, we have other CD-ROM, other drives and all, flash disk and all. So the once CPU requires a certain information, what CPU does is it takes the information from the primary memory, main memory, and it process the information. So it takes a time. So in CPU itself, there is a cache memory. It is 32 to 64 bits usually, and this cache memory helps in faster information transfer. So it is more faster than RAM, we can say. Information is transferred more faster than RAM. So in cache memory there is registers, and these registers are used to hold information that are currently processed by the CPU. So for example, if you are getting a calculation like 17 plus 10 plus 12, so in case of human, what we does is that 17 plus 10, 17, we keep it in our memory, and then again we count. So the same thing is there in the cache, the registers. So in registers, what happens is that they keep the 10 plus 17 temporarily, and then again carry out the process. So the process will be fast. So this is what happens in registers. And there are various type of registers. For example, for calculation there will be a different register. For storing data there will be a different register. So there are various type of registers available. I'll share you the presentation of various registers, but you don't require the knowledge in cybersecurity of different type of registers. If you want, you can study. Then in registers, they have each register have specific duties. Okay, so it is not like everything is combined together and gives result as it is required. For calculation, specific register is there. For memory allocation, for address finding, particular register will be there. So for each and everything, particular register will be there. So this CU, ALU, cache memory together, it is known as the processing unit. Sorry, it is known as the core. So in this core, you should understand. For example, you have heard octa-core processor, dual core processor. CPU is usually termed as processor. Everyone must know that. Then these three units, CU, ALU, and cache memory, these three are together known as core. And in this core, it can be like the system may consist of only one core, then it can be known as single core processor. If it is a combination, for example, if there are two single cores, then it will be known as dual core. If there's a combination of two dual cores, it is a quad core. Okay, so you must understand quad core processor consists of two dual core processor. Okay, then comes the speed of the processor. Speed of the processor is usually termed like n number of instructions are given, and the time taken to give the output of those instructions, that is a clock speed. It is usually given in gigahertz. Not giga, it is like, for example, if we say the speed of the system is 2.6 gigahertz, what does that mean is that it can uh, execute 2.6 billion instructions per second. So that is the how we express speed. So you understood what is core, then what is dual core, single core, quad core. Now I will say what is the 64-bit and 32-bit processor. For example, the thing is, these executions, as I told, that n number of instructions are executed in so and so time. So this execution is carried out through certain buses. We say we say these are electrical signals, which is carried out in a binary form. So the for a 32-bit system, it will have four buses. Um, sorry, yeah, four buses consist bus as a lane. So in 32-bit there will be a lane of four lanes. We say that for a 32-bit we'll have four lanes for the instructions to pass through. so that each lane will have 8 bits capacity. So that is the case of 32-bit. And in case of 64-bit, there will be 8 lanes for the informations to pass. So that becomes the 64-bit. So just by thinking in a common sense, we can understand a lane with a road with 4 lanes will be more easier to travel than will be a road with 8 lanes will be easier to travel than a road with 4 lanes. For 32-bit will be slower as compared to 64-bit. So greater than number of lanes, uh, greater the speed. So 64 will be hence more having more speed. Now we'll go to the memory layout of the program. So the memory layout of the program means this memory are stored in a particular format, and this format includes like it includes stack, heap, uninitialized data, and the text. Okay, so in this the high address consists of actually when we talk about this, the layout, the process is carried out in 2 spaces. Actually there will be kernel space where the processing is performed through system calls. So here the user can reach, or the kernel itself decides what to do with the space. In user space, that is the computational resource that is allocated to the user, and it is the resource where the programs are executed and the stored. Like example, this stack to lower area is for user space, and the higher address area is for kernel. So here the stack and heap is a method of storing. For example, in stack, think of you are keeping plates in a rack. Like you keep plates on top of one. You keep on keeping on the top. So this, if you need a plate, you take from the top itself. So this is what the in stack it occurs. Like the information is being added to the topmost layer, keep on adding to the top layer, and if the information is raised, it is raised from the top layer itself. So that is the stack. In heap, the process is like you can add wherever you want, you can remove from wherever you want. In stack, you can remove from the top only. You think of the rack of plates, you clean the plates, keep it on the top, clean the plates again on the top. Once you need, you take from the top. The same thing is occurred in the stack, and in the heap you can take from anywhere. So that is a case of heap. So in stack, small variables are stored. In heap, large amount of data is being stored. In uninitialized data and initialized data portion, what happens is that the kernel decides some static variables. So these static variables are kept in this area. And in text, there are machine language instructions that is being added. So stack is a special place in memory that holds temporary data. Okay, this is LIFO, last in first out type structure. Means as I told, the plate which is kept on top will be the plate which is kept last. So we can consider plate as data, and this plate which is kept on top is removed whenever it is required, or whenever we need to remove. So last in first out type structure. So it can hold anything from text to ASM instructions. And in case of heap, the stack stores large amounts of data. It does not have any order like earlier one, last in first out, like, so it can take in any way. Then in the memory location, so in Uh, that's all about. And now we'll come to debugger. So debugger, um, it is a debugger. Before knowing debugger, you need to know what is debugging. Debugging, it is a process of detecting and removing of existing and potential errors or bugs. Okay, so these errors or bugs can be like any issue in the source code of the application or source code of the anything. Okay, so or any issues that is being mm, happening to the system. So it is so it is called debugging. So in any tool which can debug is called debugger. Okay, so a debugger can inspect the code as it's running, track down errors, modify the code while it's running. Great for building exploits. So there are various type of debuggers. Only DBG. So only DBG, it is a debugger which used to analyze in case where source code is not available. So they check the binary code and check for the bugs. In immunity debug, they what it does is that they analyze malwares, they reverse engineer binary files, etc. Uh, while they debug. And in GDB, it is a portable debugger where it is mainly Unix-like system, which works on various other programming language, including C. Okay, and debugger is also famous in case of reverse engineering. So if you have heard of reverse engineering Android applications and all, uh, the debugger is very important because we need debugger to convert the machine learned language into source code. So JADX is the tool where JADX is there, and there are many other tools. APK tool. There are many tools that is used for debugging. Once you convert the machine non-language into source code using debugger, you can easily reverse engineer in Android applications. So these are the use of debugger. So now we'll move on to ASLR, address space layout randomization. So this is a security feature that is involved to the kernel. This was introduced to Linux kernels in 2005 itself. So it is not a new security feature. It is being added early itself. So in this, what happens is that usually hackers know the memory locations of where the information is being stored. So the memory allocated, the address, if someone know the address, they can access those area if they know the location. So what address space layout randomization does is that they randomize the location so that the hacker won't understand where the mm, particular application or the core application is located. So this ASLR will randomize the offset of core applications to they are not located in the same spot in memory every time. So for example, the stack, the heap, the shared libraries, libc, etc. are some of the uh, memory spaces, very famous areas where the hacker can access. So if their address is not known, they can't reach there easily. So ASLR, that's all about ASLR, but ASLR can be bypassed easily using various techniques. We can use ASLR, we can bypass ASLR using ROP chains. It is a exploit which helps to access the even if there is ASLR, they helps to access the address. So there is other things like EIP, EIP overwrite. This is a EIP is a register. So one of the type of register. So this register gives the address of where the location is present. So if we are able to access that, we can identify their locations. So now the virus. So virus stands for vital information resource under siege. So in a virus is usually a code. Uh, consists of components like concealer, payload, replicator. So concealer helps in the characteristic of stealthy mode. Like we won't be able to know that the virus is present in our system unless it start acting. Payload is the proper code which shows the activity of the virus, and replicator is helps to replicate to other systems and all. So in case of the help of replicator is that even after formatting, sometimes the virus can remain because with the help of replicator. So what is antivirus? So antivirus are used against virus to identify any malicious intent from the user or application. Normally it is residing in the kernel or system space to have the most reach and freedom. Actually this antivirus keep on updating itself so that it can be functioning very good way. So the usually antivirus have two modes, that is interactive mode as well as scanning mode. In interactive mode they'll be running in background. They'll be keeping on checking the processes. Like if we install something, then they will come to action. In the scanning mode is like we can manually do the scanning mode. Like at some point of time, we can scan system at the time that we want. Then usually AVs have different types of checks: signature based, heuristics based, sandbox the application. Like these are various ways. Signature based and heuristics involves like they have a library of all the viruses that have affected yet until the date. And sandboxing means they specifically observe that application in a controlled environment. So but even then the AVs can be bypassed, like the concealer component present in the virus uh, won't let the antivirus to understand their activity. So that is the case of antivirus. Now I will say some of the ring uh, that you just want to know about that. Uh, that is the one ring to rule them. One ring to rule them all. In that, the what is that is that there are actually the application layers are protection layers, and it is seen as ring levels, like ring 1, 2, 3, starting from -2, -2, -1, 0, 1, 2, 3. So this ring of protection at the outermost layer, that is the ring level 3. Ring level 3 involves the application layer, as I showed here. We can see this as layers. The outermost ring is the application layer, that is a ring 3. It has less privileges. Even if the hacker access this area, the damage cost will be less. In that ring 2 and 1, the ring which is inside of 3 will have the device drivers and all. It has privileges which is assigned by the kernel. So if the attacker access these rings, then somewhat more damage will be occurring. In case of 0, it is the kernel. So if the person accesses the kernel, the most damage it can occur. like the person can carry out have greater privileges and can carry out lot of things. In -1, it is the virtual system that is being accessed, and in the -2, it is the CPU that is being accessed. So this CPU can be accessed using various exploits that is available in the market. So that's all about today's lecture. I hope everyone understood. So shall I does anyone have any doubt? Does anyone have doubt?
No, sir.
I hope you understood something. So those who are fine can leave.
No, sir, just a minute. Hello,
Sorry.
interns. Just a minute, sir. I have to announce something.
Yes, ma'am.
Okay, hello, interns. As you all know, the Technovision is going to happen on 13th and 14th August. You know, na, everyone?
Yes, ma'am.
Yes.
Yes, ma'am.
So everyone, please do participate in it. It is free of cost for the CBA interns, and also try to bring at least one lead from your side. Okay. Okay.
Okay, ma'am.
Okay. Now you can leave, and also please fill the attendance form. Yeah, sure, Komal ma'am. I was telling about Technovision is happening on 13th and 14th August. So please do participate in it, and also try to bring at least one lead from your side. Okay, we have to complete our target of our batch. Are you clear now, Komal ma'am? Okay, ma'am. Okay, everyone. Now you can leave.